The focal distance of a parabola is the distance between the focus and the vertex. And we can use this equation to calculate it, 1 over 4a. So for this parabola, which is 1/4 x squared plus 2x minus 2, we can use this equation here. A is 1/4, so we can plug that in and solve and see that it's 1. And you can see right here that it is 1. It's one box. So the distance from the vertex to the focus is 1. Also, the distance from the vertex to the directrix is also 1. To find the focus when y is a function of x, use h, k plus 1 over 4a. And to find the focus when x is a function of y, it's h plus 1 over 4a, k. So in this example, we have the vertex at -4, -6. And remember, that is h, k. So in this case, h is -4 and k is -6. So, and since this is y as a function of x, we're going to be using this equation here. So we have h, which is -4, as our x-coordinate of the focus, and the y-coordinate is going to be -6 plus 1 over 4a, and in this case, a is 1/4. So -6 plus 1, remember this is 1, will give us the focus at -4, -5. To find the directrix when y is a function of x, use this equation. Y equals k minus 1 over 4a. If x is a function of y, use this equation. X equals h minus 1 over 4a. In this case, y is a function of x, so we're going to use this equation right there. And k is going to be the y-coordinate of the vertex, -6. And then we're going to subtract 1 over 4a. And 1 over 4a here is 1. So this whole thing is 1. -6 minus 1 is -7. And that is where the directrix is. Here is a summary of everything that we have learned about parabolas. Identify the vertex and the focus, the equations for the axis of symmetry and the directrix, and the direction of the opening of the parabola with the given equation. What is the parabola's eccentricity? Alright, so in this case, we're dealing with x as a function of y. So the vertex is at h, k, but in this case, h is -6, and k is +3. Alright, so the vertex is at h, k, which would be -6, 3. The focal distance is 1 over 4a, and a is 1/8. So we have 1 over 4 times 1/8, which gives us a focal distance of 2. The focus is at h plus the focal distance, k. So that would be -6 plus 2, 3, which is -4, 3. The axis of symmetry is at k, so y equals k here, and that is 3. The directrix is at h minus the focal distance, so -6 minus 2, which is -8. The parabola opens to the right and has an eccentricity of 1. When graphing a parabola, graph the vertex, focus, directrix, axis of symmetry, and 1 or 2 points on each side of the parabola. When selecting the points, try to use numbers that will eliminate the fraction if one exists. Alright, so since our vertex is at -6, 3, our y value is 3, let's pick 2 points above on the parabola and 2 points below. So we're going to add 4 to this y value and we get 7. And if we add 4 more, we get 11. If we plug in those y values here, we can figure out the x values, which will give us 2 more points on the graph. We can do the same thing for points below. So we subtract 4 from this and we'll get a y value of -1. If we subtract 4 more, we get a y value of -5. If we plug those y values into this equation, we get the x values and therefore 2 more points on the parabola. Here is a much nicer drawing of our parabola. Identify the vertex and the focus, the equations for the axis of symmetry and the directrix, and the direction of the opening of the parabola with the given equation. What is the parabola's eccentricity? Here we have y as a function of x. Our vertex is at h, k. H is -3, since it's x minus -3, and our k is 4. So our vertex is at -3, 4. our focal distance is 1 over 4a, and in this case, a is 2/5. So when you plug that in, we get that our focal distance is 5 over 8. The focus is at h, comma, k plus the focal distance, so that's -3, 4 and 5/8. The axis of symmetry is at our h value, so x equals -3. The directrix is at k minus the focal distance, so 4 minus 5 over 8 is 3 and 3/8. The parabola opens up and has an eccentricity of 1. Now we're going to graph the function. So I'm going to move this over a bit. I'm going to paste in the information we figured out on the previous slide. All right, so we have our vertex at -3, 4. Our focal distance is 5/8, so that will be a little bit more than half. So right there. We have our focus is at -3 and 4 and 5/8, so like right there. Our axis of symmetry is at -3, so right here. And our directrix is at 3 and 3/8. So that's like here, around there. All right, so we have our vertex right here. And let's pick a sample point over here, just so we know how wide the parabola is. When x equals 0, this is 3 squared, which is 9, times 2 is 18, divided by 5 is a little bit more than 3.5, plus 4 would be a little bit more than 7.5. So it's going to be right there somewhere. So our parabola looks something like this. When graphing a parabola, graph the vertex, focus, directrix, axis of symmetry, and 1 or 2 points on each side of the parabola. When selecting the points, try to use numbers that will eliminate the fraction if one exists. Okay, so our vertex is at -3, 4, but we're going to pick 2 points to the right, so we'll choose x values of, let's say, -1 and 0, and then corresponding points on the left. So since we moved over 2 to the right to get this -1, because -3 plus 2 is -1, we'll take -3, subtract 2, and we get -5. We'll do the same thing with the other point, so we'll subtract 3, and we'll get an x value of -6. When we plug those x values into the equation, we get the y values, and therefore we now have 2 more points. Well, we have 4 total extra points on the parabola. Identify the vertex and the focus, the equations for the axis of symmetry and the directrix, and the direction of the opening of the parabola with the given information. What is the parabola's eccentricity? Step 1. Convert the equation from general to vertex form. So we need to complete the square here. First we factor out the -4, and then we figure out what to add in. So -2 divided by 1 is -1. -1 squared is 1. So we add 1 in here. Now we don't just subtract 1 over here, because actually, since this 1 is multiplied by -4, we've actually subtracted 4 right here. So we're actually going to have to add 4 on the end. And then we simplify and we get x equals -4 times y minus 1 squared minus 5. Step 2. Identify the vertex and the focus, the equations for the axis of symmetry and the directrix, and the direction of the opening of the parabola and eccentricity. Alright, so in step 1, we converted this into vertex form. So I'm just going to paste that in here. The vertex is at h, k. Because this is x as a function of y, this is k and this is h. So h is -5 and k is +1. Therefore, the vertex is at -5, 1. The focal distance is at 1 over 4a, and in this case, a is -4, so the focal distance is -1 over 16. The focus is at h plus the focal distance, so that's -5 minus 1 over 16, since it's negative, comma k, which is 1. So we have -5 and 1/16, comma 1. The axis of symmetry is at k, so y equals 1. The directrix is h minus the focal distance, so -5 minus -1 over 16 is -5 plus 1 over 16, which gives us -4 and 15/16. The parabola opens to the left and has an eccentricity of 1.